Welcome back everyone, Houston Math Prep here. We're doing our final example on repeating integrals when you're doing integration by parts. This is not a typical one. Usually this type of repeating integral we get when we have an exponential and a sine or a cosine function. Here we've got the integral of sine of ln of x dx. So a little bit interesting because it's not even a product, right? This natural log is actually inside of the sine function, so it's really all one function dx. And so if we're doing this by parts, this is really one of those interesting things where we would actually let dv equals dx. We did those in recent videos. You might want to check those out as well. So here what we're going to do is, since we don't know the antiderivative of this, and it's much easier to do derivatives than antiderivatives, we're going to let u equal this entire thing, sine of ln of x, and we'll just set dv equal to dx. Remember in our other videos we talked about sometimes that's a way around things. If I'm integrating a single function by itself, choose it for u, then you're taking the derivative instead of the antiderivative. So here du, the derivative of sine of something is cosine of that something. So we would have cosine of ln x times the derivative of the inside, which should be 1 over x, and then dx. If dv is dx, then the antiderivative of dx is just going to be x there. So for this one, if we do that, we'll use uv, which would be x times sine of ln x, minus integral v du. So minus integral v du, I have a 1 over x in du, and I have an x in v, so when we multiply those together will become a 1, and we will just get cosine of ln of x dx. And you might be able to see sort of where this is going already. So we'll go ahead and look at doing this by parts again, since it seems very similar to this other one. So if we do that, let's look at u being cosine of ln of x, and dv is just going to be dx again. And the derivative of cosine of ln of x would be negative sine of ln of x. Chain rule times the derivative of the inside would give us a 1 over x dx again, just like before. And then the derivative of, and then if we take the antiderivative of dv there, that will give us x again, just like before. So for this one, if we're doing integration by parts, uv is going to be x cosine of ln x for the uv part, minus integral v du. We have minus, I already have a negative in terms of my du, so that would change this to a plus. And then again, similar thing happens here. We have a 1 over x and we have an x. Multiplying those together gives us 1. So integral v du then becomes integral of sine of ln of x dx. Okay, let us copy down what we have. So the original rest of the line here, integral of sine of ln of x dx. And I already have this one term that I already found in the first integration by parts, minus, and I'll need to distribute that minus. So let's go ahead and do that now. So we'll have the integral of sine of ln of x dx equal to x sine of ln x minus x cosine of ln of x. Distributing minus, we'll get minus this integral, and you'll notice this is the original integral that we started with again. So we do a similar thing that we've done in our previous videos. We simply combine like terms. We have this thing over here, and it's the same as that, so it's a repeating integral. We'll combine like terms by adding this one over to the other side. So we'll do the same thing over here, and we'll add an integral of sine of ln x dx. This obviously will become 0 over here on the right side. This part on the left, I have one of the integrals plus another integral. 1 cat plus another cat is 2 cats. So we have 2 integral sine ln of x dx, and that is equal to x sine of ln x minus x cosine of ln of x. We will have plus c after our integrals are finished, of course. And now I just need to divide both sides by 2. So dividing by 2 will get rid of that. And then dividing by 2 gives us our answer. So we'll have x sine ln x minus x cosine ln x plus c divided by 2. Okay, good luck on your repeating integrals. I hope these videos have helped you out.